Hello, my name is Nikolai and I'll be presenting on naming chemical compounds. So compounds are your basic things like, water, H2O, carbon dioxide. Now, I've been studying this for, a good couple of months because of my general chemistry class. It's a basic subject, but it's not common knowledge, and it should be really learned. So I'm gonna show you as to how to name basic chemical compounds. So our 3 main points will be cations, anions, ionic compounds, and covalent compounds. So to start off, we have the periodic table to show what elements we'll be using in our compounds. So for cations and anions, so a cation has a positive charge, such as lithium. They're mostly going to be metals. And what that means is that it lost an electron to complete its octet rule. So the octet rule is to have a complete valence shell, which is 8 electrons. So cations have lost the electrons to complete the octet rule. Therefore, it will have a positive charge. Anions will have a negative charge. So what that means is they have gained more electrons and to complete their octet rule. Those will normally be your nonmetals, your gases. And when you combine 2 different elements and they both complete the octet rule together, if they both equal to 0, your suffix will end with ide, such as oxide. The oxide is the most common one. So naming ionic compounds. Ionic compounds are strictly metal and non-metal elements. And so if you have an element that has a lesser charge than usual, it will end with an OUS, an us. And if it does have a greater charge than usual, then it will end with ig, like with an IC. So for our first compound, it would be FeCO3, which is ferric chloride. So the reason why it's called ferric chloride is because Fe, it has a greater charge than usual, so it will end with IC. And then chloride is because when you add the ferric and the chlorine, they equal out. They equal each other, or they make a balance of 0. Therefore, the compound will end with IDE. Then you have Cu+, which stands for cuprous, which is copper. Cu stands for copper, but it's cuprous because it has a lesser charge than normal copper. And then Cu+2 is cupric because it has a greater charge than your regular copper. Next, we have covalent bonds. So covalent bonds are strictly between 2 nonmetals. And these will normally be your gases. So for these prefixes, such as di, tri, tetra, you normally go up to tetra and no more than that. And these make up your basic molecules, such as carbon dioxide, H2O. So for our first one, we have CO2, which is carbon dioxide because we have 1 carbon and 2 oxygen. Therefore, it is carbon dioxide, and because they balance each other and make 0. Then we have carbon tetrahydride, which means that you have 4 hydrogens, but because the carbon and the hydrogens equal 0, it ends with ide. Then next you have hydrogen chloride, because hydrogen and chlorine together they equal 0, and while there's only 1, you only name off the 1, and they equal 0, therefore you have chloride. And all this was done by Dr. Hammerstein. She did a lot of the research.